We're taking a look here at a function table where we're told it's a quartic function, which is very helpful information because looking at the table, the first thing my eyes want to look for are x-intercepts, and x-intercepts happen whenever the y height is 0. So this is an x-intercept. That's 1, 2, 3, 4. That's exactly how many x-intercepts I was hoping for, because then I know exactly how all my factors. There's 4 factors producing those 4 x-intercepts. My job, though, is to produce a function in standard form that models this table, and so I'm going to have to be concerned about the factors and the a value. And then once I get that all set up, I have to multiply to standard form. So here we go. We're going to say f of x is equal to my a value that I'm not sure about yet, my leading coefficient. And then I'm going to do the opposite of each of these is x plus 4. This is going to be x plus 2. This is going to be x plus 1. And finally, x minus 1. So at least I got one thing going for me with that x plus 1, x minus 1 for multiplying in a minute. So x plus 1 times x minus 1 times x plus 2 times x plus 4. So I put all 4 factors just next to each other, and then I'm going to find my a value. Now, to find my a value, the most convenient place to look would be for a y-intercept, and y-intercepts happen when my x input was 0, which means that this 32 is my y-intercept. So that means I can find a with ease by saying f of 0 is 32. And then that is equal to a times, and then plugging 0 to each of these is just 1. Plugging a 0 here is negative 1. Plugging a 0 here is 2. And plugging in a 0 here is going to be 4. So now I find the a value by solving for a. Negative 1 times positive 1 is 1. Negative 1 times 2 is negative 2 times 4. So I get negative 8. Negative 8a equals 32. And then I divide both sides by negative 8 to isolate the a. And a is, as an a, is negative 4. So now I put negative 4 right there. And my job will be to distribute and simplify. So let's do that. So I'm going to put negative 4 times x plus 1, x minus 1, times x plus 2, times x plus 4. And then I'm going to take advantage of my difference of squares because I have conjugates here. This produces the difference of squares, which is x squared minus 1. And then I have these two. I'm going to go ahead and multiply them together and then distribute with the x squared minus 1. I'm going to keep in mind this negative 4 is hanging out in front. And so I have x plus 2 times x plus 4. So when I distribute, I'm going to FOIL and get x squared. And then I'm going to write up top 4x. And then I'm going to do my plus 2x. So that way down below I don't have to rewrite here. I'm just going to say plus 6x. And then finally 2 times 4 is 8. So now the only thing I have left to do is do my 2 by 3 there and then distribute a negative 4 across it. So for the 2 by 3, you can use the box method or the double distribute method. I'll set up a box over here, 2 by 3 box. So I've got x squared minus 1, and I've got x squared plus 6x plus 8. So multiplying those two are going to make an x to the 4th. And then I have a 6x to the 3rd plus 8x squared. And then down here is going to be negative x squared minus 6x, and then minus 8. Combining my like terms, be careful because the diagonals are not like terms. I've got to pay more attention than that. I've got x to the 4th, and then 6x to the 3rd. And then this negative x squared and this 8x are going to make a plus 7x squared minus 6x minus 8. So the only thing to finish is I've got to remember that negative 4 is still sitting out in front over there. So I got to bring it back over here in parentheses. Negative 4 needs to get distributed over into my result. So my final answer should be that f of x is equal to negative 4 x to the fourth, and then negative 24 x to the third, and then negative 28 x squared, running out of space here, positive 24 x, and then positive 32. So that is f of x in standard form.